IRR. Here we are taking non-conventional investments. That is, this is the case of multiple IRR or internal rate of return. This is the problem. For this project, we have to find out the IRR. This is the cash flows, minus means outflow of fund, and plus is the inflow of cash or inflow of fund. Okay. Initially the outflow of fund is minus 1000, that is outflow of fund 1000 rupees, it is in rupees, and this is inflow of fund after 1 year, this is 4000 rupees, and after second year the outflow fund again 3750. Okay, we have to find out the IRR. IRR is the discount rate at which, if we discount all the cash flows, then the net present value will be 0. We are using that concept. Okay, and this is the calculation for finding out the IRR for this problem. We know that the NPV will be 0. So we are finding the net present value in this way. This is the initial outflow of fund, and that's why it is negative sign, and after 1 year the cash inflows is 4000, and R, we are assuming R is the discount rate or IRR in this case. If you discount this to make it at present value, that's why 4000 multiplied by 1 plus R. Actually this is the discount factor. And for second year, that is after second year, the cash outflow is 3750, and that's why if we discount again, that's why this is done for finding the present value. And if you sum total all these cash flows to present value, then it will be 0 if R is the internal rate of return, that is the discount rate at which the NPV is 0. We have to find out the value of R. Okay. To solve this, assume 1 by 1 plus R is equal to X, and we have put the value of X to this expression. That's why our equation minus 1000, 4000 into X, as 1 by 1 plus R is X, and minus 3750 into X square, because this is 1 by X square. Now if we solve this, this is simply the solving of this equation, then you will get two values of X. After solving, you can check it. I have done it here, and the value of X will be 2 by 5 or 2 by 3. Two values you will get. Okay. Now if one value is 2 by 5, then after solving you will get the value of R will be 150%, because the value of R is 1.5. if you multiply it 100 to get it percentage, then the value will be 150%. And if we take the other value, that is 2 by 3, then after solving you will get the value of R is 50%. You can check the calculation, I have done it, 50%. That means in this case the value of R is 50% and also 150%. It means if you discount these cash flows considering the value of R as 50%, then you will get NPV is equal to 0. You can check it, and I will show it also. And if you discount all the cash flows considering the value of R as 150%, again the value of NPV will be 0. That's why this is a case where the internal rate of return, that is the value of R, is 50% and 150%. Now for the same problem I have shown For the same problem, I have shown the calculation for NPV, net present value, for other discount rate also, not only 50% and 150%. I have shown here starting from 40% to 160%. That means if the discount rate, if you take 40%, the NPV will be negative. How you have calculated? This is the formula. This is the formula in Excel. I have written minus 1000 plus 4000 into 1 plus R, and the power is minus 1, and that's why, and minus 3750 into 1 plus R square. If you apply this formula, then you will get the present value. Okay, and serially I have calculated the value of NPV for the same cash flows for different discount rate, and the value will be like this. You can check for this also. You can check. This is like a minus 1 and it is minus 2. You can see it. This is minus 2 in this way. The power minus 2 minus 1. By manually if you calculate, it will take a lot of time, but through Excel it is very easy. Only 2 to 3 minutes required to find out the net present value for all this discount rate. And you can check at the discount rate 150, the NPV is 0. That means 150% the cash flows, the net present value of the cash flows will be 0, which is the internal rate of return. And if the discount rate is 50%, then again the NPV is 0. But in between this, always the value of NPV is positive. And if we draw the graph, but below 50% again, if we take 40%, the NPV is negative. And if we take more than 150%, there also the net present value is negative. And if you draw this graph through Excel, the shape of the graph will be like this. You can see this is a 50%. This is the point, which point here it is taken, series 3.2, the value is 0.50. So this is this point. Again for this point you can see that is 150% the NPV. In this side, the x axis it is NPV. This side is NPV. Plot here NPV, red color. That means y axis is NPV and the x axis is discount rate. And here is the discount rate, and this is the points 1, 2, 3, 4, 9 and 10. 10th point is discount rate is 160%, at which the NPV is negative, minus 16.25, and you can check the value at this is minus 16.25. okay, minus 16.25, and it is negative 160%. This value is negative. Okay, 0. So in this way, one information message we are getting that for this specific problem, the IRR is 50% and 150%, and in between these two discount rate, all the NPVs are positive, and below the discount rate 50%, the NPV is negative, and above 150%, again the NPV is negative. That means the project should not be accepted above 150% discount rate, and it should not be accepted if the discount rate is below 50%, and in between this percent, the 50% and 150%, the NPV is always positive, and you can accept the project. This is the outcome from this calculation. Okay, now we are returning back Okay, so due to some difficulties it was would not be back. Now it has come back. Now I am going to show you one application. Sometimes in MCQ multiple choice question this type of problem may come. An investment project has two IRR, 20% and 50%. The investments NPV, net present value at 30% discount rate is 1000. Would the project be acceptable if the discount rate is 40%, 10%, 60%? Draw the NPV graph to justify your answer. Okay, this is the problem. Again I am repeating, the IRR for any problem is 20% and 50%, and at the discount at 30% the NPV is given 1000 rupees. So should we accept the project at the discounted 40%, at the discounted 10%, 60%, and also draw the graph. This is the problem. Now see, that means at the 20% this type of problem, it is a case of multiple IRR. That's why 20% the NPV is 0, the IRR is 20% and 50%, and in between all the discount rates will give the positive NPV, and the NPV is given 1000 at 30% discount, that is in between this, but below 20% the NPV will be negative. How? That I have already discussed through calculations by Excel sheet. And above 50% again the NPV will be negative, and if the NPV for the project is negative, you should not accept it. That means your answer will be in this case in between 20% and 50% discount, you can accept the project. And your question was, should we accept the project 50% or 10%? For 40% you can accept the project as the NPV will be positive, but for 10% you should not accept the project as 10% is below 20%. Okay, and at 60%, is it acceptable for 60%? No, as 60% is above 50%, at 60% the NPV will be negative. That's why you should not accept the project. You can only accept the project in this case at 40% discount rate. In this way you can take your decision, should we accept the project or not, at which percentage of discount rate. Okay, thank you. If you have any problem you can write to the comment box. Definitely I will give your reply at the earliest possible. Thank you. So this is a case of multiple IRR, and I have already shown in this way. Again I am showing you, and how the calculation is done, that is also shown through an Excel sheet. And this is the actual graph, and this is the point of IRR, this is the point of IRR, this is 50% and this is 150%, and in between the NPV is positive, it is shown here, and below this IRR discount rate the NPV is negative, and above this IRR, that means 150%, the NPV is negative. And in this way you can use this concept of multiple IRR for your application. Okay, thank you.